Hello and welcome back to the Maya Toolbelt. This is Michael. Today we're going to be looking at our fields and solvers again. So we're going to look at the effects menu, fields and solvers down here, and we have several different kinds of fields. We've already talked about a few of them as of this recording, but today let's look at radial field and go into the options. So here I'm going to edit, reset settings, make sure everything's at their defaults. So you'll notice here we have our radial field name. Just like all the other fields, you can add a name for the field in the options here, and you can give it a non-generic name. If you don't fill anything in here, it'll just use the default radial field 1 kind of thing. Then we have magnitude, which we've talked about in the other field videos we've done so far. Magnitude is, I have a little tooltip here, strength of field force, or the strength of the field itself, how much power it has. Attenuation, again, is kind of a fall off effect, and I'm using this is actually the first video I'm recording with Maya 2017, so apparently there's all these little tooltips that pop up when I mouse over things now, which definitely makes things a little bit easier maybe to explain to you guys, so I have to take advantage of that. Radial type. Alright, if 0, attenuation will decrease magnitude smoothly to 0 at max distance. So what does that mean? Down here we have our use max distance is checked on by default, and then we have a max distance of 20. The radial type here, and you see it indicates in the tooltip, if at 0, attenuation will decrease the magnitude smoothly to 0 at max distance. Okay, so the attenuation is that fall off effect, right? So the radial type value at 0 means that the attenuation will fall off gradually until it gets to the max distance. If you increase this radial type, you're increasing how fast the fall off takes place over the course of the field. And we'll get to it, we'll show it in action. And then down here we have our volume settings. Again, I'm trying to avoid going over the same thing over and over in these videos. In the air field video, and you take a look at that one over here, I do go over the volume settings there. Please feel free to look at those. They are exactly the same for all the fields. Alright, so mainly we're going to look at these guys here. So before I can actually create a field and do anything, I need to have something in my scene for the field to affect. So let's go to our End Particles menu, and then we'll look at our End Particle tool options. Alright, there we go. So I have my tool settings docked over here like I'm used to. Alright, so reset tool. So our particles, let's see, I'm going to create a particle grid, and I'll use the cursor. So we're going to create a grid like we did before. I'm going to click here, and then click here, hit enter, and it makes a grid of little particles. And we can close those tool settings like that. And I'll hide the grid. So now we just have our grid of particles. And I'm going to select these particles now, Control A to open the attribute editor. Particle shape, I'm going to change these particles to little spheres instead of little dots to make it a little bit easier to see. So here I'm going to select spheres and decrease their radius, so not giant spheres but bigger than dots. And now I'll change the background to black. I think that helps also a little bit too. So we can close the attribute editor. So now we're all set. So now we have this grid of particle spheres. Then I'm going to go to fields and solvers, radial. I'm going to the options here, edit, reset, again defaults, hit create. So the radial field, you can see it there in the middle. It kind of looks like a snowflake from this small size, but it's actually lots of little arrows pointing out from a point, which kind of gives you a hint as to how this thing works and what it does. Again, also before I can really see what happens, I need to have my animation playback settings in the UI. There's a new thing in Maya 2017. If you go to Windows, they have workspaces, and if we choose Maya Classic, it actually brings up the time slider and range slider very quickly, very easily, which I like that. And also down here, this little animation preferences button, this little orange guy. Click him, make sure my playback speed is play every frame, and hit save. Alright. And so now I have 120 frames to play with. So let's increase this up. Let's say a lot. Let's say 2,000. Hit enter. So I have 2,000 frames. So it should give me enough time to see what's going on. And now we hit play. Boom. Didn't need that much time at all, apparently. So let's decrease our magnitude a bit so we can maybe get a better idea of what's happening. Let's decrease it down to 1 and hit play. Okay, it still goes pretty fast, but not nearly as fast as it was. But you can see what's happening though. Boom, let me pause it. So the particles are just exploding outward from the point of the field. This is the radial field, remember? So it's going out in a radial pattern or radius, all directions outward from the point of the field's position. If I move the field over here, boom, you can see it all kind of shooting out. And these particles over here are going this way, all these particles over here are going that way. Now I do have use max distance turned on, and the distance is 20. So you'll notice right through here we have this definite kind of division between particles that are and are not affected by the field. Because the distance is 20, it's way out here. When I had the field centered on the grid of particles, we didn't really see that max distance border, but here with the field positioned over this direction, we can definitely see that border of that max distance being taken effect. So let's drop the max distance down to say 10, rewind, play. So there you go, you can see again that smaller area of influence. Okay, let's look at our settings here. So magnitude, we know what that is. That's how powerful the field is. We can change this to say 0.2, so it's really low, and the effect is much slower. What if we did -2, or -0.2 I should say? Rewind, play. You can see we get an inverse effect where they're all being pulled in to a point. Very similar, if you've been following along with us, very similar to the Newton field, where the Newton would pull particles in. And I failed to mention it in that video, but you can set the magnitude to a negative number to get that inverse effect. So this is essentially a Newton field when you have the magnitude set to a negative value. So Newton and radial are very similar in what they can do. It's just their magnitudes are kind of reversed in a sense. Let's take magnitude back up to positive 0.2. So then we have attenuation is on, and remember that's that kind of fall off effect. Let's change our max distance back up to about 15 so we have a larger area. Hit play. So you can see what's happening. You see how the particles are gradually toward the edge of this max distance. They're closer together. If we take this attenuation off and hit play, you can see how they all shoot out at the same rate. It's a much different result when attenuation is at 0 compared to 1. This is at 1. Okay. So now with attenuation at 1, we can use our, let's scroll down here. We have radial type. Remember that value at 0, the gradual change toward the edge of the max distance that we saw before in the options. If we change this to say 1, rewind and play, you can kind of see a much different effect. You see that? Kind of almost like a star pattern happening here. Let's say 0.5. So it definitely changes that rate back to 0 again, and how these particles move back up to 1. So you can see how there's kind of a curve effect here. If you think of this curve as being the outer edge of the attenuation, with the radial type at 1, that outer curve here is happening right through here. Take that radial type back down to 0, and you see that curve happens all the way down to the edge of the max distance. So that's what that radial type's doing. 0.25, for example, with radial type. You can see how that curve is kind of a subtle thing, but you can see how it kind of bulges out here. That curve ends around here somewhere before it starts to go to the max distance that way. So that's what radial type does. And then we have all of our volume settings, as we have talked about before briefly. You can turn volume shape on by changing it from none to one of these other ones, for example a torus. And then when you scale the field, you can scale that shape. And anything that's within the shape takes effect by the field. So you see there with the torus shape, this donut section cut out in the middle is not affected by the field, while the areas within the ring are. So yeah, that's the radial field. Very similar in a lot of ways to the Newton field. It just goes, it pushes particles outward by default as opposed to pulling them in. Again, you change that magnitude to negative and you're getting the Newton kind of effect. And again, with Newton you can do the same. So yeah, that's the radial field. I hope you enjoyed that video and learned a little bit about how that radial field works. If you have any questions or comments, please feel free to add them to the video and I'll respond as soon as I can. Thanks again for watching, and I'll talk to you later. Right at the end of the video, I just remembered something I forgot about mentioning with the radial field. So let me go back to the effects menu, fields and solvers, and I'll just make a radial field. Even though I don't have any particles in the scene, that's fine. But if I go to modify, transformation tools, show manipulator tool. If I click this, we do have some handy tools here. You can see we have this gizmo that comes on the screen, and it literally will show us these handles that we can manipulate to adjust max distance, attenuation, as well as the magnitude. And we can go down here to negative numbers as well. So you do have these kinds of little handles you can use with the show manipulator tool to interactively adjust those settings, and you can see them in here, over here in the channel box, change as I mess with them here. So yeah, I just wanted to add that part to this video, and since I'm talking about it now, let's go ahead and go back to the air field, and you'll see I have the same thing here with show manipulator tool turned on with the air field. It does also have magnitude, attenuation, max distance. Let's delete that one and go back to Newton. Again, similar things. We got, what's over here? Long handle over there. But if we zoom in here, we have max distance here, we have attenuation here, and magnitude here. Again, we can adjust these settings over here as well, but with the show manipulator turned on, we do get these little handles we can use. And if you click that little circle for this one, you see we changed to have a min distance handle and a max distance handle. Click it again, it goes back to the original attenuation, magnitude, and so on. I'm curious as to what this is supposed to be because max distance is way back here, so I don't know. That part's a little bit of a mystery to me, but we do have these two handles as well. So yeah, show manipulator tool is just something to keep in mind when you are dealing with these fields. They also allow you to adjust these settings on the fly in a much more, and I would even argue that it's much more easy to use with that sort of, with this sort of gizmo. You can kind of see that curve and how it's going to affect the field. So yeah, I just wanted to add that to the end here because I forgot about it. So here you go. Anyway, thanks again for watching. Talk to you later.